In this video, we are solving the 12th numerical from the exercise for the chapter Laws of Motion, which is the fourth chapter for the 11th standard physics. Now, as per the question, we are studying a ball. This ball has some mass initially, and then it is dropped from certain height for a total of 10 seconds. And once it reaches that 10-second mark, it explodes into two fragments. So something like this. So in terms of diagram, so we have a ball which was originally with some mass and it was traveling at some speed, and then after some time it explodes into two fragments of mass m1 and m2 respectively. Based on this, we have been given the ratio in which the mass was split. So if we were to calculate the given data as per this fact, so if the mass of the fragment 1 is m1 and mass of the fragment second is m2, then before the explosion the mass of the original ball should be m1 plus m2. So m1 plus m2 is given to us as half kg, and the ratio of split is given to us 1:2. So the mass of smaller fragment would be 1 by 6 kgs, and the mass of the larger fragment would be 2 by 6 kgs. We have just used the ratios and the mass value. That's it. So m1 is the lighter fragment and m2 is the heavier fragment. Then इसके बाद क्या बताया गया है कि the lighter fragment after the explosion travels with a down speed of 60 meters per second. We'll come to this part, but let's first find out कि originally before the explosion with what speed our ball was traveling with. So if I know that it was falling for 10 seconds under the influence of gravity, so if we were to calculate the speed of the ball right before explosion, we would say it is equal to u is equal to gt. This comes from the equation of straight line. So that is 10 into 10, that is 100 meters per second. So that is the speed of this ball right before explosion. And after explosion, it got exploded into two fragments, and we are being given the speed of the lighter fragment, which is given to us as 60 meters per second. So at this point, in terms of speed, we know the original speed of the combined ball and we know the speed of the lighter particle, but we don't know the speed of the larger or the heavier fragment yet. And based on this, what do we have to calculate? Well, we have to calculate the kinetic energy that was supplied during the explosion. So if you can see, this was the initial state. So this state might have some kinetic energy, and this was the final state after the explosion. It might have some kinetic energy, and both these kinetic energies have to be different. And the difference between these two kinetic energy must be the energy that was supplied during the explosion. And that's what we have to calculate, the difference between the two kinetic energies. So if I were to enter our 2 point section, well, we have to find the difference in the kinetic energy during the explosion. So with this, let us proceed to see what sort of formulas we'll use in this particular question. Well, the first formula is, of course, since we have to calculate the differences between the kinetic energy, we will use the formula for difference in kinetic energy, that's final minus initial. And if you, by the definition of kinetic energy, if I were to substitute the values, it would be something like this for this particular situation, where for the final kinetic energy is the addition of kinetic energy of particle m1 and kinetic energy of fragment m2, and the initial kinetic energy is the kinetic energy of this combined ball. So that's what you have done, m1 v1 square half m2 v2 square minus this is the initial kinetic energy of the entire ball, that is half of m1 plus m2 into u square. And if you see, we have an idea about v1, we know u, we know all the masses, but v2 is yet unknown. So we need to find v2 first, and one way to find velocities, if the masses and the other velocities are given, is to use the law of conservation of linear momentum, because for the cases of explosion or collision, momentum is always conserved. So I can say that the initial momentum, that is the momentum of the combined ball or unexploded ball, and the momentum after the explosion, that is the individual momentum of both the fragments, should be equal. So based on this, we can calculate v2, and then we'll simply substitute v2 in this equation to get the energy value. So let us quickly get into the solution side of it. So as per the conservation of linear momentum, as we have seen, initial momentum must be equal to the final momentum. If we were to substitute all the known values to us, we have all the values that is either given to us or been calculated by us except for this V2. So what we'll do is we'll take all the unknown quantities on one side and all the known quantities on the other side, and based on this we get an expression for V2, and if we were to solve it further, V2 comes out to be 120 meters per second. So this is the velocity with which the heavier fragment would fall after the explosion. Now that we have calculated all the quantities required for us to calculate the difference in energy, let us quickly calculate difference in energy as well. So energy supplied during the explosion must be the energy gap that was between the final and the initial energies. So simply substituting the values into the formulas, we get an expression, and if we were to solve this expression further, we get we get a simpler expression, that is 300 plus 2400 minus 2500, and if you were to solve this, we get the difference in energy to be 200 joules. So based on this question, the explosion, in order for the explosion to occur, the explosion needs to supply energy of 200 joules, so that after the explosion both the fragments would travel at their respective speeds. With this, the solution has been done. If you want the PDF of the solution, do check out the description box. With this, I hope this helped you. Thank you.